Welcome to 7.2 in the chapter Chemical Reactions. This time we're going to be talking about matter and energy. Chemical reactions can sometimes be something that happens on a bench and add two chemicals together and you get some kind of color change or you can't even see anything. However, sometimes you get a massive explosion like this one. And this is what we're going to be talking about today, the differences between the amount of energy you get out of chemical reactions, either very large positive heat-creating reactions or maybe even heat-sucking reactions. So let's get straight into it. So there are two different types of reactions that we're going to be talking about. The first type is called exothermic. Exo meaning out, thermic meaning heat. Exothermic, out heat. So that's the kind of reactions that creates heat. Okay, examples of chemical reactions that create heat are like this explosion you see just here. This is a very large heat-creating reaction. The chemical used might be any number of different things, but certainly it's got a lot of energy inside it. And then when you react it with other chemicals, maybe give it a bit of a spark, it releases all that energy in this huge fiery explosion. A less dramatic example is like the petrol in cars or in a motorcycle. You'll see that the petrol is squirted into small chambers and then ignited, and then this ignition causes the gases to expand, causing pistons to go up and down, which causes the wheels to move and the car to move forward. And that's exothermic reactions. Exo meaning out, thermic meaning heat. The other type of reaction is the type of reaction that actually absorbs energy from its surroundings. So it sucks in all the energy from its surroundings, and it's called endothermic. Endo meaning in. Endo, in, thermic, heat. It actually sucks in energy out of the air around it. So if you're touching that reaction, you'll actually see that when you do that, it gets colder. Exothermic being heat creating, like a large fire explosion. Endothermic being one that sucks in energy, like a heat pack. But we're going to give an example of that in a moment. Let's have a look at some examples. So this example is a airbag, obviously. So airbags are a large exothermic reaction. They are, well, they used to be, they're actually not anymore, but let's pretend that we're in the 50s. They are a reaction of sodium azide plus sodium plus nitrogen gas. So there is a chemical that sits in the steering wheel, being the sodium azide, and then a trigger sets that off, that causes the sodium azide to basically explode, okay, and turn into sodium and nitrogen gas. Now, it's a big heat-creating, space-creating reaction, okay? So by setting off this little chemical here, it creates a lot of space and a lot of energy awfully, awfully fast, so that it fills out this bag really quite fast, okay? And that's the idea of it. This large exothermic reaction, and this particular exothermic reaction has saved countless number of lives, so it's a very important one. Now, just as a sort of small side note, there's a good reason why they no longer use this. Sodium is, I don't know if you've ever dropped sodium into water, but it's awfully reactive and awfully dangerous, and nitrogen gas, is not very good to breathe in. So the actual contents of this bag used to be quite toxic, and most of the time it doesn't make a big difference, but it's certainly a good idea to replace it with something less toxic once they had some better ideas of how to do that. Also, sodium azide was very expensive, so they found some cheaper and safer options, which was pretty awesome. So that's a exothermic reaction. Endothermic reaction. Ice pack. Inside the ice pack there is ammonium chloride, okay, and there's water. This is, you squeeze these together, okay, it breaks the seal, and then the ammonium chloride and the water mix, okay, and you get ammonium chloride in solution, all right, and that actually requires heat, this reaction, okay, so it sucks in heat, all right, from the surrounding areas in order to create this ammonium chloride. So it feels cold, so it actually sucks in heat from your leg, you know, and it needs, you know, your heat, your leg is swollen or whatever else, and it's causing a lot of heat, okay, or having a lot of heat. So that heat is able to be sucked out, basically, into the ice pack. Okay, this is an endothermic reaction. Ammonium chloride and water, endothermic reaction, resulting in ammonium chloride. Good. Wow, we're racing through this one. Let's have a look at the last slide here. So this is a picture of Alfred Nobel. Okay, he was, you know, doing his stuff in the 1860s. The big thing that he's known for, other than the Nobel Prize, was inventing dynamite. Okay, and obviously dynamite was a huge exothermic reaction. Prior to this, the explosive that was used in industrial contexts was nitroglycerin. And as we kind of know about nitroglycerin, it's famous for being highly explosive but highly volatile. It's not a very nice chemical to deal with. Many people at the time were being killed by large explosions caused by nitroglycerin. In fact, Nobel's younger brother was actually killed in 1864 by a nitroglycerin explosion. So Alfred, you know, he thought, you know, well, that's a bit rubbish. So he bought a barge, anchored in the middle of a lake, and was determined to find a way to make nitroglycerin safer. And he did so. He combined nitroglycerin with silica, turning the liquid into a paste that could be shaped, you know, safely into rods that could be used for blowing up, you know, whatever they need to blow up. And he patented that in 1866, and, you know, the rest is history. And he made so much money that, you know, when he died in 1896, they discovered that his $9 million fortune, which I think was quite a lot back in 1896, was to be used for the establishment of the Nobel Prizes, and ever since then we've been awarding those to people that we think deserve them. So, Alfred Nobel, responsible for dynamite, a huge exothermic reaction. Good. Okay, so now what I want you to do is go to chapter 7.2, have a look at the blue words. Don't forget the section after the investigation to do with exo and endo and Nobel, and put them all into Quizlet, give them a practice, and I'll see you in class. Okay, bye.